Chip manufacturing is a valuable and rapidly growing industry, particularly relevant here in Ohio given the upcoming construction of Intel's megasite over the next decade. The industry's manufacturing processes expend hundreds of billions of gallons of water annually, which, given the ever-increasing economic and ecological impacts of water overconsumption, makes even small optimizations extremely valuable. Our goal as a group is to design an engineering-based solution which aids Intel in reducing water usage, simultaneously keeping Intel's critical needs for a solution that is cost-effective and does not compromise the manufacturing process in mind. In considering our users' needs, we had several important questions. What materials should we use? Prioritizing cost-effectiveness, we utilized 3D printing and our provided assembly kit.
How can we ensure the integrity of the manufactured process? We decided early on that critical measurements should be reliably confirmed via more than one sensor to limit system volatility. An issue of such importance that after our provided turbidity sensor failed, we manufactured and calibrated our own. In reducing water waste, we concluded that 2 techniques would be most applicable: reducing unnecessary water use, relatively simple and cheap, albeit with a limited overall capacity to reduce waste and recycling, which maximally limits wastewater, however, has more significant technological requirements.
We looked across Intel's entire fabrication process and identified 2 weak points where these techniques could be applied. Firstly, Intel's use of fixed timing system in the rinsing of silicon wafers necessitates consistently overestimating how much water each rinse requires. Secondly, all of Intel's wastewater is sent to the same place regardless of the same level of contamination, meaning Intel must pay for the purification of what would otherwise be largely clean water. Our solution is to carefully monitor contamination levels in wastewater via TDS and turbidity sensors, which transmit data to a back-end program which can signal to shut off the rinsing process once the water is clear, eliminating the need for overestimation.
This monitoring system also allows us to determine the cleanliness of wastewater and call for the flow of water to be redirected to different sources, including drinking or agricultural water, which could potentially be sold for further return on investment. The quantity and value of these optimizations is displayed on our website. The constants for flow rate, fixed rinse time, safe contamination levels used in these calculations will vary by the specific manufacturing process. However, our program is highly customizable and any of these variables can be easily changed. The strength of our software is its adaptability, and it improves on current reducing and recycling in a variety of situations while effortlessly displaying user value.